What if nuclear fusion went wrong? We often hear that fusion could be the future of clean energy. But isn't there a risk of an accident even worse than nuclear fission? Experts say no. They claim fusion is fundamentally different. No chain reaction. No meltdown. No runaway disaster. But wait. Fusion is also what powers the most destructive weapon ever created, the hydrogen bomb. So how can something used in a bomb also be considered completely safe for energy production? To understand that, we need to break down how fusion really works. Before talking about fusion, let's quickly revisit nuclear fission. This is what powers today's nuclear plants and atomic bombs. In fission, a heavy atom like uranium-235 is hit by a neutron. It splits into smaller fragments, and releases a huge amount of energy. And more neutrons. Those neutrons hit other atoms, and trigger more reactions. This creates a chain reaction. In nuclear bombs, this reaction grows exponentially, 1, 2, 4, 8, 16, that's how you get an explosion like Hiroshima. In nuclear reactors, however, we control it. Each reaction triggers only one more. But if control is lost, the reactor can overheat, melt down, and release radioactive material, like Chernobyl. Fusion is the opposite process. Instead of splitting atoms, we combine small ones. This is what powers the sun. For example, hydrogen atoms fused together form helium release energy. A typical fusion reaction, deuterium plus tritium helium plus energy plus neutron. And the energy? One single fusion reaction releases millions of times more energy than a chemical reaction like burning fuel. To give you perspective, to power a city for a year, 1 million tons of coal. Or 25 tons of uranium. Or just 100 kilograms of fusion fuel. Fusion is insanely efficient. So why don't we already use it everywhere? Because atoms don't want to fuse. They repel each other. Both nuclei are positively charged. So they push each other away. To make them fuse, you must force them extremely close. At extremely high speeds. That requires insane temperatures. We're talking about tens of millions of degrees. Hotter than the core of the sun. Here's the critical part. In fission, reactions create more reactions. This leads to exponential growth. In fusion, that doesn't happen. Fusion is actually fragile. If anything goes wrong, temperature drops. Density drops. Reaction stops instantly. No chain reaction. No runaway explosion. Fusion only works under extremely precise conditions. Lose those conditions, and everything shuts down immediately. This is where people get confused. Because yes, fusion powers hydrogen bombs. But here's the key, a fusion bomb does not start with fusion. It starts with a fission bomb. Step by step, a fission bomb explodes. It creates extreme pressure and heat. This triggers fusion. Fusion releases massive energy. Then even more fission can happen. It's a chain of reactions, engineered under extreme conditions. These conditions are millions of times more intense. Impossible in a power plant. So no, a fusion reactor cannot turn into a bomb. So, can nuclear fusion go out of control? No. Unlike fission, no chain reaction. No exponential growth. No meltdown scenario. In fact, fusion is so hard to maintain that scientists are still struggling to make it work efficiently. That's the real challenge. If you want to understand the science behind the world's biggest technologies, subscribe to the Curiosity Lab. Because the future is built on what we don't fully understand yet.